Hey, this is Mr. Janes. In this video, we'll be talking about triangle similarity theorems, or shortcuts to show that two triangles are similar. In the beginning of this video, we'll be reviewing how to show that two figures are congruent, or how to show that two figures are similar and the differences between them. Next, we'll introduce the triangle similarity theorems, or shortcuts. Lastly, we'll look at some problems to practice using the triangle similarity theorems we learned in the beginning of the video. So, let's start by reviewing the difference between congruence and similarity. Now remember, to show that two triangles, or any two figures for that matter, are congruent, we need to check two things. First, we need to check and ensure that the corresponding angles are congruent in both figures. And I'm showing that right here, these tick marks. So again, the first thing we need to show is that all the corresponding angles are congruent. All the corresponding angles must be congruent. Next, we need to ensure or check that all of the corresponding sides are also congruent. So I'm showing that here again with these tick marks. So we need to show that all the corresponding sides, corresponding means matching, all the corresponding sides are also congruent. And once we have those two things, we can say that these two figures, or triangles as a whole, are congruent. Now, similarity is a little bit different. It's the same in a way because the first thing we need to check is that all of the corresponding angles from one figure to the other are congruent. So just like congruence, all of the angles, all of the corresponding angles must be congruent. But different from congruence, with similarity, we need to show that all of the corresponding sides, such as AB, CD here, and EF, all of those sides have to be not congruent, but proportional. So that means that if I took A over B, A divided by B, that's got to be the same ratio as C to D, and that has to be the same ratio as E to F. Or proportional means that all those sides have the same ratio from one to the other. They've got the same amount multiplied or divided by to get from the side lengths of one figure to the side lengths of the other. So again, all the sides aren't congruent, they are proportional. Now, with triangles and triangles only, we have a couple of shortcuts we can use. Instead of having to check that every angle in the two triangles are congruent and every side is proportional, we can use one theorem called angle-angle similarity, which states that if you just check that two of the angles, one angle, another angle, are congruent, then in fact both of those triangles must be similar to each other. And therefore, there's no need to check any of the sides. That's pretty quick. We also have another theorem that we'll look at called side-side-side similarity. That states that if you can show that the sides, all three sides, 1, 2, 3, on the two triangles are proportional, then there's no need to check the angles. These two triangles are automatically similar. There's also one additional shortcut called side-angle-side similarity, but we won't use it very often, and so that won't be covered in this video. Next, let me show you how to use those triangle similarity theorems we just learned about. Let's start with side-side-side. Now the side-side-side similarity theorem, or SSS, this little similarity symbol, says that if the corresponding sides of two triangles are proportional, then the triangles are similar. And we don't even need to check for the angles. So let's check out these down here. Are these pairs of triangles similar? Explain why or why not. So in this first example, again, the angles are not marked, but that's okay because we're going to use the side-side-side similarity theorem, or shortcut. All we need to do is check to see if the sides are proportional. So let's see. The longest side of both of these is 12 on ABC and looks like 8 on DEF. So I would probably have to create a ratio of 12 to 8 for that first side. Then I've got, let's see, 9 to 6, 9 to 6, and lastly a ratio of 6 to 4, 6 to 4. Now, are those all the same ratio? Well, all we need to do is simplify each ratio to see if they're all the same ratio, if they're all proportional to each other. So 12 over 8, dividing both the numerator and denominator by 4, I get 3 over 2. For 9 over 6, if I divide the numerator and the denominator by 3, I get 3 over 2. And for 6 over 4, dividing by 2 in the numerator and the denominator leaves me with 3 over 2. So in fact, these are all proportional, meaning that the two triangles altogether are similar. So I would say yes, that, let's see, A, B, C is similar to, make sure I get this right, A to B is this red, 6, so D must be D, E, F. And my explanation is by the side similarity theorem. And I can abbreviate it like that, SSS, that little squiggle. Now the next one's very similar. I'm going to do it much more quickly. First, again, we start by lining up the sides and making those ratios. 4 over 2.5, 6 over 3.75, 8 over 5. And now I need to check to see if those are all the same ratio, if they're all proportional to each other. And there's a lot of decimals there, so instead of simplifying my ratios by multiplying or dividing, I'm just going to pop these into a calculator and see what I get. So 4 divided by 2.5, 6 divided by 3.75, 8 divided by 5, and I get an answer of 1.6 for all of those, which means that those must be the same ratio, the sides are proportional, and the triangles as a whole are similar. Again, I'm not going to need to check the angles because I'm going to use the side similarity theorem. And our explanation is yes, triangle ABC is similar to triangle JKL by the side similarity theorem, or shortcut as you might call it. I'd like you to try practice problems 1, 2, and 3 on your own. The directions are, in the following examples, state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. So you want to go ahead and check to see if these are similar using that side similarity theorem. Pause the video now. The answers will start coming up in 3, 2, 1. In number 1, your ratio should start like this. If you have trouble or mix up these ratios, just remember this. The longest side of one triangle should always correspond to the longest side of the other triangle. Because if these two triangles are similar, then the longest side of one figure will still be the longest side of the other. Same thing with the shortest, right? So 12 will go with 6, and for the shortest, 8 will go with 4, and I guess the middle sides should also correspond, so 10 with 5, and that's how you can line those ratios up. Next, simplifying those ratios shows us that they are all a 2-to-1 ratio, so the sides are proportional. Now we can go ahead and finish the similarity statement and write our reason. And I have that triangle DCB is similar to triangle DST by side similarity theorem. Now if you're having trouble lining these letters up, it can be tough because none of the angles are labeled. I recommend taking a highlighter or another colored pencil and matching up the sides with a different color. So like the longest side, 12, and the longest side of this, 6, I both put as red, and so on with the rest of the sides. And so it's a little easier for me to see that, okay, if the first triangle goes D to C, and here we have all those ratios, 36 to 6, 29 to 5, 24 to 4, and two of them end up being a 6-to-1 ratio, the first one and this last one. But the middle one ends up being a 29 to 5 ratio, and I put them as decimals, and you can see it's 6, 5.8, and 6, which means that although two of the sides are proportional, the third side is not. It's really important to check all three sides and not just two of them, because if you only check two, you wouldn't have seen that this third side is in fact not proportional, and so these two triangles are not similar. Not similar. Go ahead and try number 3. The answers will be coming up in 3, 2, 1. Now the difficult part about number 3 is that the triangles are actually overlapping. So it might help to get out a highlighter and highlight the two triangles. I did this larger one in green and the smaller one in yellow, and actually draw them again below to separate those two triangles so you can see how long the sides actually are. Alright, so here are my two triangles. I just copied them down from above so I can see things a little better. So for the green triangle, the sides are, it looks like 12. This bottom is 9. And this side is 15. Alright. And for the smaller triangle, I've got, well, wait a second. how long is the side right here? They don't tell me. Well, if I know this whole side from t to r is 12, and from h to r looks like it's 8, that must mean that this side is 12 minus 8, which is 4. So that's going to be 4. I'll label that in my smaller yellow triangle down here. The bottom is 3, and the side is 5. Oh, so now it'll be much easier for me to write out these ratios. If you haven't already done the ratios, write them out now, simplify them, see if everything is proportional. If they are, go ahead and write that similarity statement. If they're not, write not similar, and the answers for that will be up in 3, 2, make sure you're finishing this yourself. We did the hard part together. Here are the answers. Alright, so I did all the ratios, 12 to 4, 9 to 3, 15 to 5, and it turns out they're all a 3 to 1 ratio. So that means that the sides are proportional, and altogether I can say that triangle TSR is similar to triangle TGH by side-side-side similarity theorem. Again, I've got to write that because I didn't check any of the angles. In fact, they're not even labeled. To finish off this video, let's go back and talk about that other similarity shortcut, or theorem, called angle-angle similarity theorem. The angle-angle similarity theorem states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. What this means is that we don't need to check to see if the sides are proportional. We don't have to do any of that computation. Instead, we can just check to see if 1, 2 pairs of angles are congruent to each other, and if they are, we can say, using this theorem, that those two triangles as a whole are similar. So let's look at this first example here. We've got one triangle with angles 39 and 72 degrees, and another triangle with angles 41 and 72 degrees. So it looks like we've already got one pair of congruent angles, but remember, for this shortcut we need 2, and 39 is not congruent to a 41 degree angle. What about this last angle up top? Maybe those are congruent. To double check that, to find this last angle, we can subtract 39 and 72 from 180, because all the interior angles of a triangle should add up to 180 degrees. So subtract the 72, subtract that 39, and if you do that, you'll get 69 degrees. 69 degrees. And 69 degrees isn't congruent to 41 degrees, and neither is 39. So in fact, we don't have two congruent angles here, so we can conclude that these triangles are not similar. What about these next two triangles here? Well, we've got two equilateral triangles, and I know that because they've got two 60-degree angles, which means the third angle will also be 60 degrees. And so right away we've got 1, 2 pairs of congruent angles. So that fits the angle-angle similarity theorem, and I can say that triangle CED is similar to, let's see, triangle HGF by the angle-angle similarity theorem. Now, as you can see, the angle-angle similarity theorem is much easier to use when you have those angles nicely labeled, because we don't need a lot of that computation, no ratios to deal with. At this point, I'd like you to turn back to the practice problems, numbers 4, 5, and 6, and try these on your own. My hint is that all of them deal with the angle-angle similarity theorem, and so in all of them, you're going to have to find two pairs of congruent angles. If you can, then the triangles are similar, and you can go ahead and finish that statement. If you can't find two pairs of angles, then the triangles are not similar. Go ahead and pause the video. The answers will be up in 3, 2, 1. So in problem number 4, we're already given that angle T is congruent to angle Q. And we know that because angle T and angle Q both have these two tick marks on them. So that gives us one pair of congruent angles. But if we're going to use the angle-angle similarity theorem, we need two pairs of congruent angles. Where's the other one? Well, it turns out that angle SPT, this angle right here, angle SPT, and angle RPQ, this angle right here, RPQ, those are vertical angles. And we know that vertical angles are always congruent. They always have the same angle measure. So that gives us our second pair of congruent angles. Now we can use the angle-angle similarity theorem to say that triangle PQR is similar to triangle PTS. Triangle PTS. Now, we just shown they're similar, and we didn't have to check any of the sides for proportionality. no ratios, no dividing, nothing like that. And we didn't even have to check this third angle, angle S and angle R, to see if they were congruent. We automatically know by using the angle-angle theorem that just checking two pairs of congruent angles is enough to show the two triangles are congruent. That's pretty fast. Take a look at number 5. If you already haven't tried 5, please pause the video now and give it a try. The answers will be up in 3, 2, 1. Please make sure you're pausing and actually trying these practice problems. Even if you were confused on number 4, you can definitely try 5. Remember, all you've got to do here is to use the angle-angle theorem, try and find out if two of the angles are congruent to each other, any way you can. That includes Uchaif. Alright, here are the answers in 3, 2, 1. Alright, let's take a look at those answers. Now remember, for angle-angle similarity theorem, we need to show that two angles are congruent to each other. The easy one is to notice that angle B is 92 degrees and angle E is also 92 degrees. So that gives us our first pair of congruent angles. But to begin this problem, angle D was not filled in and angle C was not filled in, so there's really nothing else we can do. Except, remember that all the angles in a triangle must sum up to 180 degrees. So what I did is I started with this triangle here. I said, well, this is a 92 degree angle. This is 31. Add those together and subtract those from 180, and you get 57 degrees. And now, take a look at this. Angle A is 57 degrees, and I know now that angle D is 57 degrees. So that is a second pair of angles that are congruent to each other. Therefore, we can say that triangle ABC is similar to triangle DEF by the angle-angle similarity theorem. Remember to pause here and try number 6. The answers will be up in 3, 2, make sure you've tried it. Here are the answers. Now 6 is particularly tricky because in number 6 there are no angles labeled with any angle measures, any numbers, or any tick marks to begin with, so we've got to find everything on our own. The first thing I noticed was that angle SQR and angle BQA are vertical angles, which means that they are congruent. So that is our first pair of congruent angles. Great. Where's our second pair? Well, for that, we'll need to think back about parallel lines and transversals. Take a look at lines SR and BA. They've got this one arrow on them indicating that they are parallel. And line SA is a line that's connecting those two parallel lines, called a transversal. Now, remember back to what we've talked about earlier about transversals. This angle here, angle QSR, this angle here, angle QAB, are alternate interior angles. And alternate interior angles of parallel lines are congruent. So this gives us our second pair of congruent angles. You could have also used line RB as a transversal and said that angle R and angle B were congruent, but you don't need to, because all we need to use the angle-angle similarity theorem are two congruent angles. And between the vertical angles here and the alternate interior angles here and here, we've got two pairs. And finally, we can say that triangle QRS is similar to triangle QBA by the angle-angle similarity theorem. One last reminder, pay special attention when you're writing out these similarity statements. In this example in 4, remember we matched T with Q, right? They're both the second letter of these statements because T and Q were those congruent and corresponding angles. Over here we matched S and A together, again the last letter of these, because S and A are congruent corresponding angles. But they look different in 4 and 6, and so it's important to know which angles are congruent when you're writing out these statements. Great, we're all set. I hope this video has shown you how to use the side-side-side similarity theorem and the angle-angle similarity theorem to speed up showing that two triangles are congruent. Now you don't have to check every single side and every single angle. Now it's just using a matter of one of those two shortcuts.